Hello everyone, we are the team Nano Innovators and we are presenting on the topic water purification using nanotechnology. We are thankful to our mentors Shivam Patak sir, Abhishek sir and Pratyek sir. And with our team members Harish Khandelwal, Haristashva Pandya, Gulshan Verma, Mukesh Chaudhary, Anshu and Maitri. Firstly, I will start with the abstract of our topic. We all know that clean water is the global need and need of all life for all the humankind. But we also know that clean water resources are now being contaminated in present time. The water in rivers, lakes are being highly contaminated due to non-biodegradable waste. Nanotechnology is an easy approach to clean wastewater by using different methods. Different types of bacteria, toxic chemicals, etc. can be removed easily by using nanotechnology. Why nanotechnology is well suited? Because nanomaterials are well suited for water purification, disinfection, and wastewater treatment application as they have large surface area, high reactivity, high degree of functionalization, size dependent properties, affinity for specific target, contaminant, etc. Various types of nanomaterials such as antibacterial nanomaterial, carbon nanotubes, nanoabsorbents, and with the help of these nanomaterials, we can easily clean the wastewater. So now let us start with the introduction part. The technological advancement and scientific exploration is now shifted from macroscopic level to microscopic level, and in this transition lies the nanoscale, a dimension which is on the order of 10 to the power minus 9 meter. The nanoscale's unique characteristic offer a bridge between the macroscopic and quantum worlds. As we navigate this frontier, the nanoscale comes with the promise of transformative development that have the potential to reshape our understanding of the world and redefine the limits of what is possible. This plays an important role in making of materials, so-called nanomaterials. Similarly, we found the potential of nanomaterials and nanotechnology in water purification. So, why there is a need of water purification? The goals of the treatment are to remove unwanted consequences from the water and to make it safe for drinking and other specific purposes in industry and medical applications. The choice of method will depend on the quality of the water being treated, the cost of the treatment process, and the quality standards expected of the process.
Brief about electrospun nanofiber. First of all, we will see how electrospun nanofiber is fabricated. In this process, the process of fabrication, we need a syringe pump, a syringe in which polymeric solution is filled, a pair of electrode, a collector which is rotating and closed environment. Once voltage is applied and gradually increased for some moment, we will see a Taylor cyclone is formed. This cone is formed because of at this time cohesive force, which is attraction force between two liquid particles dominates over electrostatic force. Further polymeric solution in a single line where cohesive and electrostatic force are balanced out. On further increasing voltage, electrostatic force dominates over the cohesive force and hence vaporizing solution moving towards collector. On collector, it gets absorbed and hence making a nanofiber. This is how electroform nanofiber is formed. Now let us look how we use electroform nanofiber for purification of water. Basically, for mass purification of water, the water used to go through the process in which uh, they need to go for three processes: primary treatment, secondary treatment, and tertiary treatment. Before water moves to the primary treatment, it moves forward for pre-primary treatment place in which large particle which is greater than 0.2 millimeter is removed. Then this water is moved for the primary treatment in which up to zero point 0.1 nanometer particle gets filtered out. Further secondary treatment process takes place in which is also known as biological treatment in which biodegradable organic and inorganic particles break down, and this water is moved for tertiary treatment in which nanofiltration is used. In this nanofiltration, electrospun nanofiber is used for filtrating. It filtrates protozoa, bacteria, and viruses, and hence this is how the nanofibers are useful.
explain water purification using zero-valent metal nanoparticles. Silver nanoparticles are highly toxic to microorganisms and thus have a strong antibacterial effect against a wide range of microorganisms, including virus, bacteria, and fungi. As a good antibacterial agent, silver nanoparticles have been widely used for the disinfection of water. When silver nanoparticles are in contact with bacteria, free radicals can be generated. They have the ability to damage the cell membrane and considered to cause the death of cell. Other explanation for the death of cell caused by silver nanoparticles, in addition, as DNA contains abundant sulfur and phosphorus element, Ag nanoparticles can act with it and thus destroy. Other method of water purification by zinc nanoparticles. Most study on contaminant degradation in water and wastewater treatment by zero-valent metal nanoparticles have been focused on iron and zinc particles. Zinc have more negative standard reduction potential, so contaminant degradation rate of zinc nanoparticles may be faster than that of nano-zero-valent iron. For the application of nano-zero-valent zinc, most studies have been focused on dehalogenation reaction. By comparing the reactivity of various types of zinc, zero-valent iron and zero-valent zinc, it was found that zero-valent zinc could degrade CCl4 more rapidly and completely than zero-valent iron under favorable conditions.
So let's discuss about water purification using carbon nanotubes. There are several forms of carbon nanomaterials such as carbon nanotubes, carbon beads, carbon fibers and nanoporous carbon. Carbon nanotubes have gained considerable attention owing to their unique thermal, mechanical, electrical and chemical properties. Significant features that makes carbon nanotubes emerging into water purifications are fast water transfer, large surface area, fast kinetics, selectivity towards aromatics, ease of functionalization, etc. Carbon nanotubes are graphene sheets rolled up in cylinder diameter as small as 1 nanometer. High absorption efficiency for contaminants such as dichlorobenzene, ethylbenzene, zinc, lead, copper, etc. The interstitial space between carbon nanotubes would be utilized as a reinforcement of the mechanical strength of the membrane through the filling material and as a transfer path of water molecules. Meanwhile, diffusion along the outer surface of the CNTs can increase water transfer by hydrophobic surface of CNTs or the nano-confinement effect via densification process as shown in figure. According to their structures, CNT can be classified into two types, multi-wall carbon nanotubes and single-wall carbon nanotubes. In recent years, both multi-wall carbon nanotubes and single-wall carbon nanotubes have been applied for the removal of contaminant of water. These are references which we used for research this topic. I want to thank you all for watching and your attention. Have a great day.